Okay, hi everyone. So we've had a look at binary and linear searches, and we're going to move on now to the sorting. And the first one we're going to do today is the one that's affectionately called the bubble sort. Okay, so a bubble sort, it's used to sort unordered lists. Okay, the algorithm that we use, the algorithm that actually does it, is very simple. Okay, it's a very, very simple one. Okay, but it can often take a while to actually sort a list, but it's a very simple list to sort. Okay, so let's go through the algorithm first of all, and then we'll have a go at it. Okay, so the idea is I'm going to use some playing cards here just to kind of help us. So I'm going to pick some nice easy ones. 5, 7, 4, and 3. You can do this with any amount. It's going to use some small, simple ones to do it with. So, obviously it's perfect for things like sorting things into numerical or alphabetical order. Now you can do it pretty simple because your brains are just built to be able to do this thing, but you have to be able to have some type of algorithm to tell a computer, in other words, to code it. So the idea is you look at the first two items in the list. Okay, so in this case, I'm going to look at the 5 and I'm going to have a look at the 7. Okay, if they're in the right order, so if we're ascending order, we want to go in ascending order. Okay, so it's going to put that ascending. So I want to sort these in ascending order. If these are in ascending order, then I want to make sure that they're, look at the first two, and if they are in ascending order, so that's first step. Okay, check if the first two are correct order. So that's our first job. Okay, so we're going to check what the first two are in the correct order. Now, if correct, do nothing. If incorrect, this is the important thing, swap. Okay, so let's have a look. Correct order, do nothing. Okay, so what's our next step then? Move to the next pair. So that's the first pair. This is the next pair. Okay, so just don't be confused here. First pair, second pair, third pair. You get the idea? Okay, move to the next pair and repeat step 2. Okay, so far so good. So let's have a look. Step 1, check whether the first ones are in order. If in order, do nothing. If incorrect, swap. So they are in order, do nothing. Step 3, move to the next pair. Okay, repeat step 2. If they're the correct order, do nothing. They're not in the correct order. If incorrect, swap. So that's what I've done. Okay, so now what do I do? So I've had to initiate this part of the algorithm. Move to the next pair and repeat step 2. Okay. Get the idea? So check if check if they're in order, do nothing. If not, swap. Return back to the start. If they're in order, do nothing. If not, swap. If they're in order, do nothing. If they aren't, swap. If they're in order, do nothing. Check again. Okay. If they're in order, do nothing. If they aren't, swap. If they're in order, do nothing. If they're in order, do nothing. If they aren't, swap. They're in order. Okay. So that's it. Okay. So you can see as you pass through, you could have multiple passes. Okay. So I'm going to show you this with numbers. And we'll come back to the cards in a second. So, because you could be asked to write this down. Okay. So we're going to use bubble sort to sort these numbers. 66, 21, 38, 15, 89, and 49. Okay. So we're going to go through the first pass. Okay. Check that the first two are in the correct order. If they're not, swap. Okay. Check to the next pair. Okay. Swap. Check the next pair. Swap. Check the next pair. That's okay. Check the next pair. Well, we got here 49 and 89. So that's the end of the first pass. So when I get to here and I've got bubbled up 89, that should be at the top. I go back, I'm going to do it again. Okay. So check this. Okay. So on the first pass, nothing. Sorry. On the first swap, nothing. Then we're going to go so that was this one swapped. This one doesn't need to be swapped. This one does. This one doesn't. Go back again. This one doesn't. This one doesn't. This one doesn't. And you're done again. Okay. So we'll just check, where did the second pass happen? Okay. So first pass happened. The second pass started here. Okay. We did one swap to get, we swapped those. Didn't swap. Swap those. Didn't swap. So there's the second pass. And then this is the third pass. Gives you that swap there. Okay. After the second pass, okay, you should have 21, 15, 38, 49, 66, and 89. After the third pass, you should have 15, 21, 38, 49, 66. Okay, because there's no swaps, so it'll still, that was the third one. So on the fourth pass, because there's no swaps, it'll terminate. Okay, so you can see why it's a bubble, because on the first pass, something should bubble up to the surface. Okay, you should always get something bubbling. The biggest number should bubble up after the end of the first pass. At the end of the second pass, the second biggest number should bubble up. Okay, at the third pass, the third big, and sometimes you won't even need to go past, but that's the idea. Okay, okay, it can be it's a very efficient way to do. Okay, now here's a little tidbit. Okay, and this is a nice one to remember. For n items, okay, for n items, you only have to do n minus 1 passes to check if ordered. So if I have 1, 2, 3, 4, 5, 6, okay, the max I'll ever have to do is 5. Now, I didn't even, only 4 was the max I needed to do there, 4 passes, but okay. Now, where's the efficiency here? The efficiency here comes from the fact that we're using the original list. Okay, we're using the original list. So it doesn't use up much memory. We're not having to store them in new lists or anything like that, or new bits of memory. It's the original list, the original memory. It's very easy to do. Okay. It's not very good with big numbers though. Okay. It's not very good with a very big, large list because you're still, if I had a list of 1 billion, you're still going to have to go down to 1 billion minus 1 to find it or to sort it. Okay. So, that's the trick with it. Okay, that is the trick with the bubble sort. Okay, so hope that makes sense. Now let's have a look at it with some cards. I don't know if I can get another one in, but I will try. I think I might. I'll get one more in. Okay, so let's sort it from smallest to biggest. Okay, first pair, swap. That's an order, do nothing. Next pair, swap. Next pair, swap. I don't know why that. Sorry, I got that wrong, did I? I don't know why I swapped that. There was no need to swap that. Wasn't thinking straight there. Sorry, start that one again. So, first pair, don't swap. Second pair, swap. Third pair, swap. Fourth pair, swap. So the first pass, I have a queen where it should be. Now, after the second pass, I should have a jack there. Let's see. First pair, do not swap. Second pair, swap. Third pair, swap. Fourth pair, do not swap. So it's where it should be after the second pass. Let's say do it to the third pass. First pair, swap. Second pair, swap. Third pair, do not swap. Fourth pair, do not swap. Okay, that's the third pass done. Let's do one more pass. First pair, swap. Second pair, do not swap. Third pair, do not swap. Fourth pair, do not swap. Okay. Do your last pass. Do not swap. Do not swap. Do not swap. It's sorted. Okay. So that's how you do it. As I said, it is pretty quick to learn, easy to understand, but it does have frailties. Big, huge lists do not work very well with it. Okay. And when we talk about efficiencies, when we compare all these sorting and searching algorithms later on, we'll have a better chance to talk about the efficiencies on them. Okay, for want of a better word. Okay, so that is the bubble sort. So we're going to move on right now to the insertion sort. Okay, now this one is a bit more tougher to understand. Okay, but we'll give it a go. Okay, so this is an insertion sort. Okay. Let's think about it for a second. Okay. The idea of an insertion sort is it takes each item and puts it in the right spot. Okay. So let's do the algorithm for this one. Okay. So step one, you take the second item. Take the second item in a list. Number two, compare it to all items before it. Okay. And insert into the right place. Number three, repeat 2 for the second, for the third, the fourth, and the fifth, etc. until the last number in the list has been inserted correctly. So, listen, easiest way to do that is, let's give it a go. Okay. So, let's see, bowl. Star. Pull. Tiger. Let's see, scrum, kite, and roll. So I want to put these into alphabetical order using an insertion sort. Okay, so we start with start. Use the second one in. You compare it to the one before it. If it's in the right position, in other words, if the one before it is of a, in this case, alphabetical order, the one below it is a letter less than S, it's where it's meant to be. Okay? So it's in the right spot. Okay? Now, let's check pull. So we're going to pop pull, okay, between bowl, because I'm looking at the two below it, and it's definitely before that one. Okay, so it's going to be bowl, pull, start, tiger, scrum, kite, and roll. Okay, so now I'm going to look at tiger. Okay, and I'm going to look at start, and tiger is definitely after start, so it's in its right location. Okay. Now we're going to look at scrum. Scrum becomes now this one. Scrum, and this is a tough one now. Okay. Yeah, I'm just trying to think of this one. Insert. We're going to insert scrum between post and start, pull and start, aren't we? Because it's before that, but it's not before that. Yeah. So bowl, pull, scrum, start, tiger, kite, and roll. So these are all now in the correct order. The next one we have to look at is kite. So we look at the ones beforehand. So we're going to look at kite. It's definitely before there. It's definitely before there. It's definitely before there. And it's definitely before there. So we're going to pop in kite between bowl. So we're inserting it. Kite and pull. Okay. And finally, we check roll. Roll is definitely before tiger. So we're inserting it between pull and scrum. Okay, so bowl, kite, pull, roll, scrum, start, tiger. Okay, and there you have it. You've inserted it. So insertion, let's do it again. You start with the second one on the list, you compare it to the first one. If it's in its right place, you move on. Then you compare the third one in the list to the first and the second. If it's in its right place, you leave it. If not, you insert it where it's meant to be and you move on. And you keep doing that. So you keep looking at the end of the list. So what you can see is happening is the tail, as you move to the right, the tail is already ordered. Okay? So it has lots of advantages. Okay? It's very easy to code. Very easy to code. Okay? You can use it with very small lists. Okay? So like bubble sort, it's all done on the one list. You're not using up lots of memory. Okay, it's very quick. It's very quick, and because you're ordering as you go along, it's easy to add a new one because then you can just slot it in the right spot. Okay, and it's also very easy because unlike the bubble list where you have to that last one, you have to check each pair that they're correct. With this list, it is correct because you're only checking the last one. You don't have to go through them all again. Okay. The other problem, of course, the problem is you're going to have very, 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 very a lot of iterations to get to that last one. So with a very big list, again, it's not the best one. Okay, so just like the other one. So I hope that's the first two anyway, the bubble and the insertion. We'll come to the other ones the next day. Thanks, Nick.